All right, everyone, we'll get started here. Welcome, everyone, to the Moldex3D webinar series. My name is Alex Baker from the Moldex3D North America office here in Farmington Hills, Michigan. Today, we'll be talking about what's new in Moldex3D 2025. This session is going to be split into 4 sections. We have project management and usability, solver capability and database, preprocessing and integration tools, and then molding innovation, what new features we have available coming or what features have been improved in the 2025 version. As you may have seen, our development roadmap is focused around 3 main categories: automation, optimization, and intelligence. And so you'll see a lot of the new features and new capabilities in Moldex3D are going to be driven by these 3 goals. All right, starting off with project management and usability. I'm going to start off with a couple of the heavy hitters here. First of all, we have a new integration or a new capability through our DOE function. Instead of just being able to run the typical DOE, which you still have the capability to do, we have a new option here called the AI Optimization Wizard. This, instead of setting up individual data points, will be able to set a range instead. And so that range, this AI Optimization Wizard will test within this range to get to the optimized value. In this case, we have max injection pressure. You can see that it runs several iterations along the way to achieve the lowest injection pressure possible. In addition to this, the DOE now has a real-time interactive prediction so that you can click and drag any of these control factors, because we already know what the sensitivity looks like, and see the resulting impact on the quality factors. So as I drag these up and down, you can see that we already know what that sensitivity looks like, and so we can tell what the resulting output would look like if we change some of these input parameters. So awesome new tool that allows us to get more versatile output from the DOE function. We've also added an enhancement to the DOE to optimize factors with some more flexibility. For example, you can change your flow rate, not only the flow rate value, but you can also change things like your profiling for your flow rate. You can change your profiling for packing pressure and these sorts of things. You can optimize these intermediate sections of the flow rate profiles rather than just changing the magnitude like we could in the past. And also along the lines of AOI, on the automation side, we already have an API capability where you can script Moldex3D to run certain functions for you. This function has been available since 2021. However, we have implemented some new functionality in 2025 to increase the flexibility and capability of this API function. From the modeling and mesh, from the process, and from the result interpretation side in creating the report, we've introduced a lot of new capabilities for the API, and you can go to our What's New on our website to get more details for what specific items have been added into the API. There's quite a few of them. For fiber orientation, we have improved the graphical representation of the fibers. Previously, they were just a bunch of vectors, and actually the vector heads were what looked like the tails of the vectors. So we changed that around a little bit. We improved this to look more like a fiber, and the probability still is going to be indicated by the color. The relative direction or the probability of the direction of these fibers or the orientation of these fibers are going to be indicated by the visual representation. And this is also reflected in 2-dimensional type of fillers like flakes and things like that. The support, we're now supporting the result criteria input. So we can set the criteria for certain values in our results, things like the weld line meeting angle, pressure, clamp tonnage, all of these things. And you can get a real-time output. Once you run the simulation, you can get an indication of whether or not the criteria has been met. So you can see here we get a check mark and a red X to give us a go or no go type of response from the simulation. Rather than having to interpret the results, we can just get a real-time output there. This has been a very highly requested function in Moldex3D. We have now added a view cube into our interface, so you can route around the different orientations and viewports a little bit easier rather than having to use the dropdown. We'll now have the view cube for all user interfaces so that you can interact with the model a little bit easier and get your model into a report ready format as simply and quickly as possible. In addition to this, we've also introduced some more functionality to the view angles. So we could always change the view angle by double clicking on this on the coordinate axes. But now you can add world coordinate systems, user coordinate systems, that's WCS and UCS respectively. You can change where your coordinates and view cube are located in your user interface and so on. From the measurement side of things, we have two new items. So you might be already familiar with the distance tool and the roundness tool and measuring face. But now we've added two more items for parallelism and perpendicularity, which allow you to measure how a selected face, how perpendicular that face is to a selected plane. For perpendicularity, that is how perpendicular it is. For parallelism, it's how parallel it is. So they're very similar tools, just kind of opposites of one another. And they'll give you an indicator, kind of like the flatness tool. It'll give you an indicator of how perpendicular that surface actually is to the plane that you've selected. This also opens up the functionality for datum planes. So we're going to start introducing some more capabilities on the datum plane side for measurement. In addition to parallelism and perpendicularity. These both lay the framework for some additional tools that will be introduced in the next coming versions. Now, I mentioned a moment ago that we have the ability to change our result criteria. We also now have a verification template where we can import or select multiple different items that might be related to a particular run. So for example, the result list, which was added in 2024, allows us to modify what results are showing up in our result tree. Result criteria is what I just mentioned. Result setting, these are things like the your clipping, slicing, isosurface. Result note, if you put any notes into your result items, you can import all of those for any run, and you can do this across different projects as well. So I can take this information from one project and import it into another, or if you want to use the Moldex3D defaults, you have the capability to do that. But this just kind of localizes everything and allows you to select everything all in one step rather than having to go to 5 different buttons. It just kind of brings them all into the same spot. The Compact Project Wizard Plus has always been an application that Moldex3D had access to. When you install Moldex3D, even in the past, the Compact Project Wizard was there, but I think not a lot of people knew that it existed, just because it was never upfront in the interface. So we've added the Compact Project Wizard into the Studio interface now under the Utility tab, and this allows us to remove some of the unnecessary files from our projects. As anybody who's run simulation knows, these project files get very big very quickly. And so being able to remove some of the redundant information enables us to drop the size of our projects considerably. There's 3 types of files that you can remove from your project if you've never used the Compact Wizard Plus before. You can remove temporary files, exchange files, and intermediate time step output files. Temporary and exchange files, these ones you can always remove. These are just created by the solver. But intermediate time step output files, these are your time steps for the simulation. So if you remove these, you'll no longer have access to them. But these are usually the bulk of the size of your project. So if you remove these time step output files, you can considerably reduce your project size. From what I've seen, the percentage varies between 60 and 80% of your project size is in these time steps. There's also an item here that allows you to keep the important time steps. So you can keep things like the VP switch or the foaming switch or compression switch, these sorts of things you can keep. But we would remove all of the other ones. The computation parameters now allow you to customize your time step refinement. So for example, if I have 10 time steps, those are going to be equally spaced along the filling stage or the packing stage. Let's say I only want 5. Let's say within these 2 time steps, I want 5. I can now go into my add time selection and I can input a start time and an end time and how many time steps I want in that time duration. So it really helps to make the time step selection process a little bit more automated, whereas before we would have to go in and automatically readjust these timings one by one. So this just really helps with the automations, or really helps with the efficiency side of setting up the time steps in our analysis. All right, and then we also have a new display tab a new display option for symmetry. Before, when you create a symmetry model, you see the symmetry when you first set up symmetry, but then once you're outside of symmetry, it kind of goes away. So now the symmetry function exists within the display tab. There's a new checkbox for symmetry model, so you can turn on that symmetry model and see what it looks like from a total model standpoint. And in addition to that, we also have an extreme value finder. This extreme value finder will be available for any result in Moldex3D. So if you right click, you'll see extreme value finder, and this will allow you to find the highest value of a particular result item. So for example, in this core shift, you can see that the core deflects quite a bit. And then once the material gets around to the top side, it kind of shifts downwards. So let's say I want to find when that maximum displacement value occurred. I can use the extreme value finder to see at what time that maximum displacement occurred and what location that highest displacement occurred as well. All right, so for the solver capability and database, these are more on the results side and on the solver side. So the first thing, and maybe the most important thing, is the introduction of what we call weld surfaces. So for anybody that's run Moldex3D before, you already know about weld lines. So you can already see these weld lines in the current version of Moldex3D. They just show as red lines across the part. If you run the weld line particle tracer, now we'll have a new result called weld line particle. And this will, the weld line particle will be output by the weld line particle tracer. But now we'll have a new result item called weld surfaces, which is going to be a surface traced by how far those weld line particles traveled after the weld line was formed. So this will give you a better idea of where you might see the visual weld line show up on the part. We've already seen some success with this welding surface for that prediction. And there's some other smaller things that show up in this slide. You can take a screenshot of this slide if you'd like to review it later, but I think this is the biggest one. From the cooling side, we have the ability to input thermal pins. The thermal pin is pretty much just a rod that will go into your cooling channel. In the future versions, we are going to be figuring out the mechanics of the isobar, which is kind of a dual phase sort of object for cooling. There's a condensation and evaporation sort of mechanic that we're still trying to figure out, but we do have the ability to consider a metal rod going into the cooling channel. This is both for geometry and line-defined systems. From the warp side, we have a new crystallinity model called Dual Nakamura. And this crystallinity will also be able to be checked in the warpage stage. So before, you could only really check the crystallinity up until the end of cooling. But now the relative crystallinity result will show up in the warpage stage of your analysis, which allows you to visualize this crystallization in things like annealing and even thermoset um, uh, applications as well. For optics, we now support the output to Zemax. Before, we only supported the output to Code 5, but now we have the ability to output to Zemax, which is another optical software. And you would need to set up a new boundary condition called the optics. I think it's just called an optics boundary condition. And then you would, in the computation parameters under VE optics, you would select output to optical software and select the Zemax software from there. From the material side, we've updated and upgraded actually our navigation for certain materials. So we've added some additional items that you can search for and separated the filler type from different types of fillers. So you can look for both the fibers, you can look for the aspect ratio of your fibers. So we've just given some more capability to that search function, similar to what you might have already seen in the MHC. And then we've added several materials into the database, a lot of them focused around the PCABS family, but we're looking to add more and more materials. Keep in mind, this is just for the official release that will be happening in September. However, these materials are continuously updated, and each sub-release or each revision of Moldex3D will have a similar number of materials updated. So this isn't just from the 2024 version to the 2025 version. This is pretty much from the last version of 2024 to the first version of 2025. So keep an eye on the what's new coming out for each version to get a feel for how many materials are added per version. All right, and then from the pre-processing side, we've added a lot of new tools for surfacing. So we've added some extrusion functions. We've added extracting faces from a mold die. This will help with extraction of cooling channel surfaces, of part surfaces, cooling compression zones, these sorts of things. We've already seen some and used to some good success. All right, the auto heal function. We had a lot of a long amount of time to import the models for auto heal. So now we've added some more tolerancing for the auto heal function. You can either use the auto tolerance or you can create a user defined tolerance for the model import. This will help with making sure that the model is as clean as possible coming into Moldex3D, so that the auto heal function doesn't have to work as hard to clean up the model, and it also comes in a little bit quicker as a result as well. All right, so a little bit more on the cooling channel extraction side. We also have a new cooling channel loop wizard that can help us to not only extract the channels, which we've already been able to do, but you can also use this tool to loop these channels together and create one continuous geometry or one continuous line of cooling channels, either with a bridging function or a intersect function or baffles, bubblers. All these sorts of things are available through this cooling channel loop wizard. It really helps to condense all of the functions for creating cooling channels into one interface, so that you're not just faced with the entire tool tab and then have to figure out what tools you should be using. This cooling channel loop wizard really helps to localize all of those tools and creates a good output for, or creates a good interface for all of those functions for cooling specifically. All right, and so there is a new input for a bunch of for any sort of mold geometry that you import into Moldex3D. You'll see that all of the you'll get a message that'll ask if you want to keep the original colors of your cooling channels or of your mold components as they were in your CAD system. So it'll be able to read those colors into Moldex3D automatically. From there, as far as the cooling is concerned, you can extract the center lines. And then you can connect all those cooling channels using the cooling channel loop wizard, like I just mentioned. And then there's also there's also an auto calculation for the cooling channel loops that will help to reduce any redundant lines or really just focus on what lines are actually useful in this cooling channel loop. In the past and in 2024, you'll see that when you create cooling channels using lines, the intersection of those lines will create kind of like a cutout or an elbow, I should say a lack of an elbow. It'll just be a couple of colliding cylinders. And so in 2025, we've added the option to preview the joints. Now, we won't do this automatically just because the rendering of those joints can take a really long time, especially for a complex cooling system. And depending on the performance of your graphics cards, we don't want this to be a limiting factor for your modeling process. And so you do have the option to preview the joints, and you can set your preferences for previewing the joints over in your preferences menu. If you want to always see the cooling channel elbows and modify those joints, you can do so. We've made a new advancement into our seating display. So when you're node seating, there's two different kind of stages of node seating. So the black ones, I'll say the uncolored nodes here are kind of the uninteracted areas. But then there's two types of interactions that you can use. You can use a sync seating, which if you're syncing the seating, for example, to the part, this is a function that we introduced back in 2023. We can take an object and sync the seating for that object to an existing object. So for example, if I'm trying to do a core shift analysis, or if I'm trying to do a very comprehensive thermal analysis, then I want to make sure that the node seating is as similar as possible. And that's where the sync seating comes in. That will be represented by a blue color now in our node seating function. And then green is going to be indicated as a user-defined node seating. So before we kind of turned all the surfaces orange. Now the feature lines will turn green as an indication that you have already fixed that or already changed the global node seating to some other value. All right, and then the entire workflow for matching mesh in Moldex3D has been improved. We have an auto matching solver. If you just turn on matching mesh, the solver will try to calculate it automatically. But even if you wanted to do a manual matching, we do have an auto copy paste function, and that really has been improved in the 2025 version to help to match all of those meshes together rather than having to do the very tedious manual matching methodology. And here's what that auto copy paste function looks like. We have a lot of new parameterizations. We have a lot of new tools that allow us to help or that help us to match all of the mesh automatically rather than having to delete the face, copy the face, then stitch the face to the new one. We can do that automatically a little bit easier now. Sharp angles are a kind of a pesky error. They're not something that we always need to go in and fix, but when they're a problem, they are kind of a pain to get rid of. So sharp angles will happen when you have two surfaces coming together at kind of a knife edge, and it's really difficult to fill that volume with solid mesh. So what this function allows us to do, we have a new fix sharp angle function, which is kind of very, very similar actually to the fix aspect ratio function that we added a couple of versions ago. And it just adds another layer of elements pretty much along this, along wherever you have any sharp angles. And that helps to increase the relative angle in that area. So, a great new function to help and reduce the possibility of mesh errors because of the sharp angle. All right, and then we've also added a stitch T connection function, which helps us to kind of divide a surface based on a face. So if you have a overlapping surface, it helps to fix that, and then you can go through some manual meshing effort to stitch that into your main mesh. All right, and then a couple of additional functions that we've added. This is actually a pretty interesting one. I haven't used it to too much of a good deal yet, but we're able to copy a feature from one location to another. So let's say I have this rib and I want to copy this rib several times. I can just copy this mesh to here, and then the automatic function will stitch that mesh into the current mesh, and all of that is done automatically. You don't have to manually do anything there. We've also added the ability to sketch quadrilateral elements. Before we could only sketch triangular elements, but now you do have the ability to sketch quadrilateral elements in addition. This helps with the creation of structural mesh, but can also help in certain regions of the part where you want to create a quadrilateral element instead of a triangular element. All right, and then from the molding innovation side, we have three sections of improvements: compression and foaming, and then IC packaging and our plastification analysis through ScrewPlus. For compression molding, pretty big change to the process condition is that the cooling is now a part of your compression time. So before, the compression time input was just the amount of time for the compression surface to go from wherever it started to wherever it should finish, and also how long it was going to stay there. But that assumes that there's a constant pressure being applied. There is now an input to say when that pressure is no longer applied, so that the part will stay inside of the mold. But that will all be incorporated into the compression time. So you're going to have your compression time and then your mold open time. Those are the only two time inputs that you're going to have in compression molding going forward in Moldex3D. Over in the cooling tab, there is no more cooling time. That is going to be a part of compression time now. And in addition to that, from the modeling side, we've introduced some new capability for creating a compression zone for vertical surfaces. If you wanted to separate different areas of your compression zone, our solver is now able to handle that to some degree. That there's if there's too much separation, if there's a lot of vertical surfaces across the part, the solver is still a little bit finicky sometimes, but we are able to handle some simple cases with vertical surfaces. And for injection compression molding type of applications or transfer molding type of applications, the meshing solver will now retain the matching of the mesh between the part and between the runner and the part, so that you can generate your compression zone mesh a little bit easier. All right, for foaming, we're using a mean field homogenization. We've always used this for determining what our cell distribution looks like. But from the warpage side, we didn't really use that information. It was more just for showing where the bubbles would be in a higher concentration, where there would be bigger bubbles, where there would be smaller bubbles. But that information wasn't directly taken into the warpage solver. So now we have incorporated that mean field homogenization over into the total displacement. Instead of using a standard warp type of methodology, we're now able to support the enhanced warp type of methodology for those foaming applications. And for chemical foaming, we now have a new model that allows us to maybe more directly control the amount of foaming that happens. And this has been already seen to improve the accuracy from the simulation to reality, although it does require some inputs from the material supplier. So we have a new constant number density model instead of the classic nucleation model. We have a new model that helps us to improve the accuracy of that foaming. From the IC packaging side, we now support the debonding of the wires from the substrate, or I should say more of the probability of that debonding. This is going to be a wire debonding index. So the higher the value here, the higher the probability that that wire is going to be swept away from the substrate or the chip or whatever it's connected to. And so this wire sweep analysis has always been something that we could run, but we really had to go through Rhino or some other meshing software to get this mesh. Now that we have a nice methodology for creating a structure mesh in Moldex3D since 2024, we can now support this wire sweep type of analysis. All right, and here's just another look at what that wire sweep is going to look like. So the pressure of the melt coming across these wires is going to dictate how likely it is for that wire to be swept away or broken from the surface it's connected to. All right, from the meshing side, we've made some more improvements to the auto generation tool for IC packaging. This was supported since 2023, I believe. But we do have some more capabilities and more flexibility for creating that auto-generated hybrid mesh or structure mesh in Moldex3D directly, rather than to have to go to an external mesher. All right, and you can get some more details as far as what functions were actually implemented. I know it's a lot of text here to read very quickly, but you can get a better idea of what functions were added by going over to our website, and I'll have a QR code at the end of this session so you can find that. All right, and then from the ScrewPlus side of things, if you don't know, we have a type of analysis called Plastification, where we can input the type of screw in our barrel and the check rings and all of this information, the nozzle type. We can input all of this information, and we can get an idea of what our maybe from a fiber length perspective, if there's going to be fiber breakage in the barrel, if there's going to be a temperature variation in the barrel. Usually we just assume at a melt entrance that we have a homogeneous condition. But this type of analysis tells us whether that assumption is going to be viable, or if we need to model a little bit more than just the runner. Maybe we need to include the nozzle. Maybe we need to include a little bit of the barrel. This type of information can be quite useful in figuring out what the homogeneity at the melt entrance should actually look like. And then from the input side, you can always find the plasticizing and ScrewPlus from the advanced setting. If you're using machine mode in our process conditions, you can find the plasticizing, which will allow you to input your barrel information, and then ScrewPlus will allow us to input some other information that you can run the analysis straight away in the process wizard, and you'll get an output for the temperature variation. And you can see some of the other outputs over here. All right, once again, you can see some of this information. You can see all of this information over on our website, moldex3d.com/2020 /what's new 2025. I'll have a QR code actually right here. This QR code will bring you over to our website, and you can see all of the new features and inclusions into the Moldex3D 2025 version. I've included a bunch of the key features that we've included into Moldex3D, the AI optimization wizard, following along the development path of automation, optimization, and intelligence. Weldline services, the new view queue, which I think a lot of people have requested. The parallel coordinates plot as an output from either the AI optimization wizard or the typical DOE, and then some new GD&T tools will really help to make the process of running simulation and interpreting simulation a little bit more fluid, versatile, and makes Moldex3D easier to use overall. All right, some of the upcoming webinars that we'll have, we have the LSR in silicone. If you're interested in getting a little bit more familiar, a little bit more intimate with how the silicone molding process works in Moldex3D, what people might be looking for, what outputs are even available from Moldex3D from the LSR side, you can watch that webinar. we have an AOI, or automation, optimization and intelligence webinar happening on August 19th. If you want to figure out how you can better match the pressure from simulation to reality, I encourage you to watch the webinar on August 20th. And then we have a tips and tricks, a pair of tips and tricks webinars coming up as well. So you can sign up for those using this QR code with your phone's camera, or you can always go to Moldex3D.com and search for webinar topics under the Americas location. All right, finally, we have 2 social media outlets that you can follow to get any sort of relevant, either the new information for 2025, what events are coming up, what information is available, what partners we are working with, if there's any Antech papers that we've published. That information will always be available on LinkedIn. And then for tutorials in using Moldex3D, and key features, tips and tricks, all of this sorts of stuff will be available over on our YouTube channel, Moldex3D North America.